Alright, so the second thing we're going to do in this unit is we are going to talk about graphing quadratics in standard form. So the first part of the unit, we talked about all things vertex form. We were able to take our vertex from that form, we were able to calculate what A is, and able to go ahead and graph in that regards, or come up with an equation based on being given a graph. Now we're going to be in standard form. Notice how this standard form is different. There are no parentheses. Essentially, it's like taking vertex form and just multiplying it out, where A, B, and C, these are all going to be numbers, okay? Now in our first example, you see that there is not an A in front of the x squared, but remember, there's always assumed to be a 1 there if there's no number there. So in that case, A is 1, B is -4, and C is 5. Now, the quickest and easiest way to graph something like this is to grab your graphing calculator and to use the table and graph it that way. It's going to save you the time from having to take all these x values and substitute them in individually. For instance, if I substituted in 0 in place of each of the x's, I would have 0 squared minus 4 times 0 plus 5, which my output would end up being 5. That's a pretty straightforward one because of the zeros, but as you get into more and more bigger numbers, that's going to just take you a little while in order to calculate all of those individually. So instead, let's take this thing and let's throw it in our graphing calculator. So if you have your graphing calculator handy, go ahead and get it out, and I'm going to bring up my graphing calculator on the screen here, and I'm going to go through the steps it takes in order to find the table in the graphing calculator. So first, you're going to hit the Y equals button in the upper left-hand corner, and then you're going to clear out anything that's already in there. If I go too fast or you miss a step, just pause me and rewind me. Okay? In this place, we want to put x squared minus 4x plus 5. So the X button is that button right below mode, the one that is highlighted in red right now. That is your X. Do not use the multiplication X. Okay? The squared button is right there, halfway down the left-hand side, so that's our x squared. Now be careful that you use a minus instead of a negative. The negative is down at the bottom. This is minus 4x plus 5. So your y equals should look like the y equals that I have on the screen here. It'll look a little different if you have a different model of TI-83 or 84. Okay? So now I'm going to hit graph just to get a quick look at this graph. So graph is your upper right-hand corner, and this at least will just give me an idea of what my graph is going to look like. There it is. Now I can't just go to my paper and roughly sketch this. That is not good enough. Okay, so really what I want from this is to look at the table. Now as I go back to my slide, notice that the table that's given to me are x values of 0, 1, 2, 3, 4. Those are the ones that must be important because those are the ones that are given to me. So I'm going to press, in order to get your table, you press the second button in the upper left-hand corner, and then you hit graph again because the second function of graph is table. And here you see all these points. The ones I'm concerned with are the x values of 0, 1, 2, 3, and 4. I see the point 0, 5, which we already had down, and then I see 1, 2, 2, 1, so I'm going to jump back over here, and I have 1, 2, 2, 1, and then 3, 2, and 4, 5. 3, 2, and 4, 5. And you should see some of the symmetry there after we get those points. So let's go ahead and let's plot these points. So this is the point 0, 5, an x value of 0, y value of 5. This is the point 1, 2. And so on and so forth. We're going to go ahead and we're going to plot these on our graph, and then we're going to sketch our parabola. So to the left and right 0 and up 5 is going to leave me 1, 2, 3, 4, 5 right about here. 1, 2 is to the right 1 and up 2. 2, 1 is to the right 2 and up 1. Right 3 up 2. I just totally missed that one. Okay, it's not going to let me do that, so hold on a minute. To the right 3 up 2, right about there, and then to the right 4 and up 5. So my parabola looks like this. So what's going to be the axis of symmetry? Well, we know that the axis of symmetry always goes through my vertex. My vertex is right there, so there's my axis of symmetry. That value always relates to the, by the way, let's just circle this here. This is our vertex, all right? The x value of our vertex is always going to be our axis of symmetry. So this is x equals 2. That's the equation for our axis of symmetry, the dotted green line. The vertex is the point 2, 1. The y-intercept, being the point where this function crosses the y-axis, is going to be the point 0, 5. That's where I cross the y. I got a little sloppy there. Let me try that again. And then the question of which direction does this thing open? Well, it opens up. So this vertex would be considered, it has a minimum. Okay? I'd like you to pause right now, and I want you to try the second example in your workbook on page 49, example B, 1B. Go ahead and try this one on your own. Okay, so now that you've tried this on your own, let me go ahead and grab my graphing calculator. It occurs to me here, well, let me change this table real quick. Okay, sorry about that. Just wanted to adjust that table real quick and make sure it was correct in line with what's in the workbook there. So let me go to my graphing calculator here, and I'm going to go back to my y equals, and I'm going to clear out what I had in there. And now this time I want to put in 2x squared plus 4x plus 1. I'm going to hit graph just to get a quick look and see what the parabola looks like. Get an idea where I'm at. Okay. Looks to me like my vertex and my axis of symmetry is going to be at an x value of -1, which probably lends some explanation as to why the table is the way that it is. So the table they gave me looked like this. So those are the x values I'm looking at on my table. Okay, so I have that -1, -1 looks to me like that's the vertex, because then everything reflects around it. So I have -1, -1. And then as I go back to my calculator, I see -2, 1 and -3, 7, and then that reflected going the other way. So these are the points that I'm using in order to graph this. So -3 up 7, -2 up 1, -1 down 1, 0, 1, and I'm not sure what happened to my +1 there, somehow it got moved over, but 1, 7. So there's my parabola. I have my axis of symmetry right there at -1, so that's x equals -1. My vertex is this point right here, because everything reflects around that, -1, 1. My y-intercept, remember, y-intercept is nothing more than when the x value is 0. So 0, 1. And this thing also opens up. So that means it has a minimum. All right. The only time that you're going to have a parabola that faces down is if that lead term, in this case it was a 2 in front of the x squared, if that were a negative, then that flips the quadratic over the x-axis.